Okay, so next one we're going to do is example 11-17. This is for non-sinusoidal waveforms. So here this is a pulse wave where you get a boop of voltage and then boop of voltage and then boop of voltage, boop voltage. So each pulse of voltage is 1 microsecond, and the time between pulses is 10 microseconds. And the question is, determine the period, the frequency, and the duty cycle for the pulse waveform. The period of any waveform is the time between it takes the wave to repeat itself. So obviously, in this case, this is very straightforward. The period is 10 microseconds. The frequency then, frequency is 1 divided by the period. So that's 1 over 10 microseconds, which is 1 over 10 times 10 to the negative 6 seconds. Well, 1 over 10 to the 10, 1 over 10 is a tenth, so that's 0.1. 1 over 10 to the negative 6, that's 10 to the positive 6 hertz, because 1 over seconds is hertz. So that's a 10 to the 6 hertz, that's a megahertz, so it's 0.1 megahertz. All right, 0.1 megahertz, which now the book wants that in kilohertz, so we convert that. 0.1 megahertz would be 100 kilohertz. The duty cycle is then pretty straightforward. That's the amount of time it spends at high voltage versus the total cycle of the wave. And that is, of course, 1 microsecond out of 10 microseconds, which is 0.1, and that is 10%. So that is our answers to this. Now it says, related problem, a certain pulse waveform has a frequency of 200 kilohertz and a pulse width of 0.25 microseconds. Determine the duty cycle. Okay, so now we're saying your frequency is 200 kilohertz. Okay, so that's 200,000 hertz, or 200 times 10 to the third hertz. So period is 1 over frequency, which is 1 over 200 times 10 to negative 10 to the third hertz. Okay, I think I'm just going to do this straight up. That's 1 over 200,000. Okay, I'm going to use a calculator. So just run that through the calculator, I get 0.000005. Or did I make one too many zeros? I never trust my math. 1, 2, 3, 4, 5, 0. Okay, I'm good. All right. So, okay. And then that would move my decimal point 1, 2, 3, 4, 5, 6 to the right. So 5 times 10 to the negative 6 seconds. So that'd be 5 microseconds. Okay. Well, that makes sense. This was 10 microseconds and it was 100 kilohertz. So that's double the frequency. It should be half the period. Okay. So 5 microseconds. And then it said the pulse width is 0.25. So I got 0.25 divided by a overall period of 5, right? So that is going to be 0.25 divided by 5. Put that into my calculator also. 0.25 divided by 5, 0.05. So that's 0.05, which is a 5% duty cycle. So that's example 11-17, and I'll give a check in the back of the book. And then I probably better only do one more, else you are going to get way sick of watching this video. Okay, those answers checked out. Now, the last one I did. Now I'm going to go do 11:19. I had a question about 11:19 about the slopes of voltages that change. Okay, so 11:19 says, what are the slopes of the voltage ramps in this figure? And I've redrawn them up here. Okay, slope is rise over run. How much it goes up or down, because you have a negative rise. And run is how far it goes sideways. In this case, the rise is voltage and the run is time. So it's your voltage change over time. So in this one, you go up 10 volts, you rise 10 volts. You run 5 milliseconds. So your slope is equal to 10 divided by 5. 10 volts divided by 5 milliseconds is going to be 2 volts per millisecond. That's your slope. Over here, your rise is negative 5 volts because it went down 5 volts. Your run is 100 milliseconds. That's your time. This is your volts. So your slope is negative 5 volts over 100 milliseconds, which is going to be negative 0.05 volts per millisecond. Now let's look at the example, the related problem. It says a certain voltage ramp has a slope of 12 volts per microsecond. If the ramp starts at 0, what is the voltage at 0.01 millisecond? Okay, so slope is equal to plus 12 volts per microsecond. Okay, well, then your time is equal to 0.01 millisecond. Let's move that over 1, 2, 3 decimal points. That will be 10 microseconds. So your time, 0.01 milliseconds is 10 microseconds. So I gain 12 volts every microsecond, and I got 10 microseconds. So then that's going to be 12 times 10 is 120 volts, and the microseconds cancel out. So there's my answer to this example problem.